Welcome back. We're going to continue our discussion on the topic of chemical kinetics. And the topic for discussion is instantaneous versus average rate. Now, just as the name sounds, this actually is what we're going to do. Instantaneous versus average rate. So I got two different types of problems. You can expect either one of these on our exam or exams outside of our class. The first one is, say concentration of a species at 20 second is this, and at 40 second is this, and you're asked to find average rate, and I'm also going to say an instantaneous rate at, say, 20 seconds. Okay, average rate is basically, rate is nothing but change in concentration, right, over change in time. So average rate means you got to have two times and two concentrations. Simple as that. So average rate equals, well, basically you want to pick the big and the small, or small minus large. It really doesn't matter. But you can pick to be 0.54 minus 0.30. I mean, if you're talking about reactant, technically 0.3 should be in front, but again, it's not that big of a deal, over your corresponding times, which is 20 minus 40. You would eventually get the negative out there, right? The corresponding time is, so you'll have a negative. So this is the time, and this is the concentration. Keep in mind, units are very, very important in any branch of science. It doesn't have to be chemistry, just any area. So we got 0.24 divided by, I've already taken the negative out of here, so it'll be 20. So it'll be divided by 20 is, so this is the rate, 0.012 second. Okay. Keep in mind, rate is always molar over second. Okay, so this is the rate, and rate is usually not negative, so you can assume this to be the absolute value of it. Rate cannot be negative. Okay. Anyways, that's average rate. We're going to do instantaneous rate as well, which is at 20 seconds. So rate is still molar over second, right? So you put at 20 seconds, the concentration is 0.54 molar over 20 seconds. So instantaneous rate is that particular time. Average is everything from start to finish, or any interval you choose to work with. So in that case, in the top case, we worked with not from 0 to 40, but between 20 and 40. An instantaneous rate at 20 seconds means at that very particular moment what's happening. So it's 0.54 over 20 is 0.027 molar per second. So this is how average and instantaneous rate works. Now the problem could be written just this way, so you know exactly what's happening, or it could be graphical like in here. I could ask you, what's the average rate for the entire reaction? Okay, average rate for the entire reaction, which would be, this is the time, 0 and 100 seconds. So 0 minus 100, okay, seconds. This is for the entire reaction. I didn't say from a particular time to a particular time. It's 0 to 100. And then the concentration, obviously, at 0 is 0 molar minus whatever the final concentration is at 100 seconds, which is, sorry, at 0, it's 0.25, 0.24, I'm sorry. I'm terribly sorry. At 0, the concentration is 0.24. I need to go to maybe 6th grade to learn to read my graphs. Minus, at 100 second, you can say it's about 0.01 because it's half of it. So you don't need to be too accurate, because people that offer these exams have answer choices that are further apart. So they know that you are going to make some assumption as far as the second number goes, but that's a really small value, so it's divided by 100. So again, you would get a negative, treat it as absolute value. Okay, so it'll be 0.0023 molar per second. Now this is for the entire reaction. What if I ask you the instantaneous rate at 40 seconds? All you got to do is pick 40 seconds, draw a line till it connects the graph, and then draw a line back from the y-axis. Wherever this line touches, you draw. So the concentration at 40 seconds is 0.06 molar over 40 seconds, which would be, it's 0.0015 molar per second. There you go. These are primarily the two ways this concept could be tested, okay? Or they could also ask you what's the average rate between, say, 60 and 80 seconds. In that case, you would do a line here, connect this, or 60, and then 80, connect this line. And then, so these will be your numerator, which is essentially the idea of slope. So 60 minus 80 is 20 seconds in the bottom. And whatever the value at the top would be about, 0.03 minus 0.01, roughly. Like I said, you have to make some whole round assumptions. So it's 0.02 over 20, which would be 0.001 molar per second. So I've shown you multiple ways on how this problem could be tested, either on our class or concepts outside of our class. Whether you're taking an NCLEX, pharmacy, dental, medical exams, or a GRE chemistry exam, then you will see these concepts being tested this way. All right, and I want you to be ready for it. So stay tuned for additional videos on the topic of kinetics.